Now we will see machine learning types, and at the end of this part you will be able to explain machine learning types. You will start to feel confident about machine learning. If you start to search machine learning related topics, you probably hear some terms like supervised learning, unsupervised learning. These are very popular terms in these days and machine learning types. In this video, we will see these terms and cover all other machine learning types. Actually, there are three major categorizations in machine learning types. Each categorization has its own criteria. For example, if try to categorize machine learning types based on human supervision status in training, then we can say that there are four machine learning types as supervised learning, semi-supervised learning, unsupervised, and reinforcement learning. But if you categorize machine learning based on if the learning process is incrementally on the fly, then you can see two different types as online learning and batch learning. Lastly, if you want to categorize machine learning based on if there is a comparison on known data points or a model is built, then you can see two different types, instance-based learning and model-based learning. As you see, there is no only supervised or unsupervised learning. There are some others, and we will see each of them one by one. Let's start with supervised learning. According to the human supervision in training process, we have four different learnings. First one is supervised learning. As you understand from the name, training process is fully supervised and guided with answers. Training sets include desired solutions. In other words, output of each input is known in supervised learning. Datasets should be fully labeled. Classification and regression algorithms are well-known supervised examples. We will see binary classification project phishing detection in our future videos. Let's assume that you want to develop a cat detector application. You have a dataset which contains cat images and other animals. If you know the labels of each image in the dataset, then you can use supervised learning algorithms to classify unseen image by your model. These are core machine learning supervised algorithms. Don't forget, you should have outputs, labeled dataset in supervised learning to train the model. And second machine learning type is unsupervised learning. It is the opposite of supervised learning. Training sets don't include desired solutions, answers, or outputs. In other words, output of each input is not known. If you have an unlabeled dataset, you can use unsupervised learning algorithms. Clustering algorithms are common unsupervised learning algorithms. Think same example in supervised learning. You want to build a cat detector, but you don't know the labels of each image. The model can cluster cat images and other animal images. Then you can label the cat images to use in a supervised learning algorithm maybe. Today, supervised learning algorithms are quite successful. Unsupervised ones are also successful, but not like the supervised ones, at least now. Generally, I can say that unsupervised learning needs more computational time and problems are more complex. But you can obtain very good results in clustering models. For example, here you can see different clusters. These can be your customers, workers, or products. After this clustering and some analysis, maybe you can discover distinguishing properties. Now, I just want to ask a simple question. This is a very well-known interview question in data science related positions. You try to cluster your data. However, it is too complex and so many features are available. So, how do you simplify the data without losing too much information? The answer is dimensionality reduction. Idea is simple. Combine several correlated features into one. I will not give details about that to keep the video in a reasonable time, but you should search what dimensionality reduction is. If you work with an unlabeled dataset and try to use unsupervised learning algorithms, it can be helpful for you. Okay, let's continue to look machine learning types. I think the same example, in this case, you have some labeled data, but also you have some unlabeled ones. As you can estimate, this is semi-supervised learning. Training sets partly include desired solutions. That's why its name is semi. Output of some inputs are known. This type is usually a combination of previous two ones actually, and Google Photo or Meta or Facebook's speech recognition applications use semi-supervised learning in their applications. And these are common semi-supervised learning algorithms. Finally, this is our fourth machine learning type in terms of human supervision in training. And reinforcement learning, it is different from the previous ones. First thing that you should know, reward and penalty approach is available here. System must learn the best strategy or policy to get the most reward over time. Especially in the game applications or educational applications, this type is quite beneficial. Like AlphaGo, it's a popular one which uses reinforcement learning. Okay, if you want to summarize that, in supervised learning, in unsupervised learning, you don't know the outputs of inputs in the training phase and you can cluster your data set. But in the supervised learning, you can build your model based on inputs and outputs. These are quite successful. Semi-supervised learning is a combination of these two. In reinforcement learning, after each action, the state will be updated with a penalty or a reward until the agent finds the best strategy, and this penalty reward will maintain. Okay, now we will see online learning and batch learning. Here, the criteria is if learning process is incrementally on the fly or not. In batch learning, system is incapable of learning incrementally. That means system will be trained with all available data and there will be no learning on the fly. If you want to update the system should be trained with new data and old data in each case. It is quite simple, often works fine, but if data is too much, especially training phase can take too much time. Therefore, sometimes it's called offline learning. And online learning is opposite. Systems keeps learning on the fly. Each learning step is fast and cheap comparing to the previous one. Therefore, it's also a good option if you have limited computational resources. And I want to ask a question at this moment. Which one is better? What do you think? Batch learning or online learning? Of course, it depends. If you want to build a system which classifies decay fruits in a gene factory, yes, you can collect images for all possible versions of fruits, then probably you will not need to update your dataset too much. You can buy enough sources for the system and dedicate for the model. In this condition, batch learning will be better for you. Let's look at important notes for online learning. A minor note, out-of-core learning is a kind of online learning, but because dataset is too big, it is usually offline. Therefore, instead of online learning, sometimes people prefer to use incremental learning. Learning rate is also an important parameter. You should not determine it as too high or too low. If it is too high, model will quickly forget all data, but if it is also too low, learning will slow and less sensitive to noise. And the last one, you should be careful about the new data, because if it is too bad, not representative, or sometimes manipulative, it affects model performance. Therefore, monitoring the system closely will decrease the risk in the online learning. Okay, now last categorization. We will see instance-based and model-based learning, and we will finish this section. And in instance-based learning, basic idea is system learns from the examples by heart, then generalizes to new cases using similarity measures. For example, we have a training instance like shown in the graph, a triangle and a rectangle. If a new instance is given, in the instance-based learning, we calculate the distance to the nearest ones, for example, and then classify the new instance according to this distance, the similarity with existing ones. However, if I look at the model-based learning, we build a model to classify new inputs. In this graph, model is represented by this dashed curve. And instead of calculating the distance or similarity, we check the new example based on this model, then classify it. With more examples and practice, you will easily understand machine learning types. Don't forget that these machine learning types are not exclusive. I mean, a spam filter tool may learn on the fly using a deep neural network model, and using spam and ham examples. That means this spam filter is an example of both online learning, model-based learning, and supervised learning. Okay, now we learned what is machine learning, what is the difference between machine learning and the traditional approaches. We saw different application examples, and lastly, we learned all machine learning types. Now, we will see machine learning challenges and, of course, solution proposals for these challenges.